Hey students, so in this notes of 6.9, it's putting all the theorems together that we've learned in this unit 6. One of them is, for example, that through the example or the polynomial given, we can identify how many roots, how many rational roots will be identified based on the degree. So here, the highest exponent is 4. That means the degree is 4. And with that, we can identify that there will be 4 roots in this graph if we were to graph it on the calculator. So that's one of the theorems. Another one is the rational root theorem, and this is not something I've explained in class yet, so let me explain this through the examples today. But pretty much, it just means that you can identify the possibilities of all the possible rational roots you can have based on the factors of your constant and the factors of your leading coefficient. So you gotta look at your polynomial and identify the leading coefficient, which again happens to be like in the front, very front of a polynomial function, and then the constant, which is the last number by itself without variables. So I'll show a couple of examples with that. And then you create this fraction of the numbers, whatever numbers you have. At the top, you're going to write the factors, all the factors of the constant. And then at the bottom is all the factors of the leading coefficient. And then you got to think of the positive and negative possibilities of each number. So all the possible combinations. So I know this is just a lot of information, but I'll show you some examples in a little bit. That, again, will tell you all the possible roots that you can have. But this tells you how many roots you can have based on the degree. All right, another thing we talked about in class is the remainder theorem, which you can identify if a factor is a factor of the polynomial. You have to have a remainder that will equal 0. So whenever your remainder is equal to 0, for example, here, if you evaluate this function in this polynomial, you're going to be looking at writing it. If you want to use PEMDAS, you're going to check if that is a factor for this polynomial by substituting the number inside each x right here. So you're going to have, for example, 4 times 2 to the 5th power minus 2 times 2 to the 4th power minus 2 to the 3rd power plus 5 times 2 to the 2nd power minus 2 plus 1. So I'm just replacing each x here, substituting the 2 in there. And then we follow this through PEMDAS. So this will result in 4 times 32 minus 2 times 16 minus 8 plus 5 times 4 minus 2 plus 1. And then after that we multiply, so then we're going to get 128 minus 32 minus 8 plus 20 minus 2 plus 1. And then if we add and subtract all these together, we're going to get 107. So that means we're going to have that the function, when x is 2, you get 107. 107 being your remainder. So this is one way to calculate if you're going to have a remainder. But we also learned that we could do the remainder theorem, which was through synthetic division. So, for example, the number that they give you, or the factor, for example, this would look like x minus 2. We're going to use the number 2, and we're going to use all the coefficients, 4, -2, -1, 5, -1, and the constant, +1. And we're going to use synthetic division. So this is where we bring down the number, and then we multiply across. 4 times 2 is 8. And then we bring down this by adding or combining these two. So then you get 6. And then you multiply across. 6 times 2 is 12. And then you bring this down and combine these two and you get 11. And then you multiply these two. You get 22. Then you bring these two and you add, you get 27. And then you multiply and you get 54. Then you bring these two and you combine and you get 53. And then you multiply those two and you get 106. And then you add these two and you get 107. So we still get that remainder of 107, but it's just through synthetic division. So what you want to do is use synthetic division because it's faster, and your goal is to get that remainder to be a 0. If it is a 0, then what you are dividing by is a factor. If it's not a 0, then it's not a factor or a rational factor. Rational root, sorry, right here. All right, the last theorem here on this paper is talking about how we can identify if a root is a factor, which is just kind of stating that any point that you have, whatever number this is, that's going to be seen or identified in the factor, written as x minus a number. So whatever this number is, the factor is x minus that number. All right, so with these theorems, I'm going to go over the 2 examples in the back right here on the left side, and then you can practice the practice problems on the right side. All right, so what we're going to do first is look at the polynomial and identify the leading coefficient, which is 4. And we're going to identify the constant, which is -1. And then also identify the degree, which is 3. The 3 is telling us that we're going to have at most 3 roots that are going to be rational. So we're going to come up with a combination of a lot of roots, and then we're going to do the synthetic division to check which ones are the 3 roots that we are going to have, that will touch on the x-axis. All right, so for example, the theorem was plus or minus p over q. And once again, p is the factors of the constant. And then q is the factors of the leading coefficient. So the constant is -1. So you just have plus or minus 1 over factors of leading coefficient. Leading coefficient is 4. So the factors of 4 are 1 times 4 and then 2 times 2. So this is your setup for your combinations of the possible roots. For example, let's list them all as all possible roots. And that's going to be a positive 1 over 1, because 1 divided by 1, positive or negative, a positive or negative 1 divided by 4, a positive or negative 1 divided by 2. So these 3 result in 6, because 1 divided by 1 is 1, but that's a positive 1. And then you have the negative 1. And then you have 1 divided by 4, which is 1/4, so that's a positive 1/4. And then you have the negative 1/4. And then you have 1 divided by 2, which is 1/2, so you have the possible 1/2, and then the negative 1/2. So this means that out of these 6, only 3 of these are the possible, the 3 roots that this graph is touching when you put it in a calculator. It's touching the x-axis. So you're going to determine which of the possible roots are actual roots. That means you're going to use scratch paper. So I just have notebook paper right here. And you're going to use synthetic division and divide one at a time with the coefficients. Like I said, using synthetic division. So we're going to try the first one, which is the positive 1. I'm just going to write the little 1. And then the coefficients are 4, 4, -1, and then the constant is -1. So we're going to do synthetic division. Bring this down. Multiply. Bring this down. That's 8. Bring this down. These add up. So then we're going to have 7. And then multiply. And then bring this down. And then that's 6. So this is your remainder. This remainder is not equal to 0. So this is not a root. All right. So that one, not possible. Next, -1. So then we're going to try -1. Same coefficients. 4, 4, -1, -1. And I know that this is time consuming, but it's just math. We just got to do it. Bring down the 4. 4 times -1 is -4. These two, if you combine them, they cancel and they give you 0. 0 times -1 is 0. And then we bring down these two, so that's -1. Multiply these two. -1 times -1 is +1. And then when you bring these down, you do get 0. So this is the remainder of 0, which means that this works. This is one of the actual roots for this function. So we're going to keep going with this until we get our 3 possible roots. Based on the degree, we should have 3 of them. So we know -1 is one of them. Okay, we're going to go ahead and try the others. So it's 1/4. And you're just going to set it up. We're also going to try -1/4. And then we're going to try 1/2. That's why you needed scratch paper. And then -1/2. So out of these combinations, only 3 will give us the remainder of 0. So let's try these. So 4 comes down, 4 times 1/4. That's dividing into 4 pieces, so it's 1. 1 times, no, so this is adding 5. 4 plus 1 is 5. Okay, so then we multiply 1/4 times 5, so it's going to be 5/4. Okay, and then on this one, because you have, of course, a whole number and a fraction, you can use your calculator if you want. You're going to do -1 plus 5/4, and that's 1/4. So then we do 1/4 times 1/4. And if you know your facts, it's numerator times numerator and denominator times denominator, but I'm just going to show you right here. It should be 1/16. This is 1/16. And then we're going to do -1 plus 1/16. And that's -15/16. So that's definitely not it. Okay, so we're going to continue with the next one. Let's try the 1/2 since those are easier. We can do 4 times 1/2, which is cutting it into 2 pieces, so that's 2. And then we add these 2, so that's 6. Then we multiply 1/2 times 6, so that's cutting it in half, so it's 3. Then we add these 2, so that's +2. Then we multiply 2 times 1/2, which is cutting it in half, so that's 1. And we add these 2, and that's 0. Oh, so this one is a remainder of 0, so that's what we want. This checks. 1/2 is also one of the roots. And then we check the other half. We're going to do 4 times -1/2, that's -2. Then you add these 2, that's +2. 1/2, -1/2 times 2, that's -1. And then you add these 2, and that's -2. Negative times negative is positive. 1/2 of 2 is 1. So -1 plus 1 is 0. So this is also a remainder of 0, and this also checks. So these 3 are the possible 3 roots. No need to do the other one because definitely we already got our 3 possible roots. So that is how we do this. This is how we put all the theorems together. and identify by hand the roots of the polynomials. All right, so let's try one more example. We're going to do all the possible rational roots based on the theorem of the combination of plus or minus p over q. So p again is the factors of the constant, and q is the factors of the leading coefficient. Here in this example, we're going to have the leading coefficient of 9, and then the constant of 2. The degree is 3. So because the degree is 3, we're going to have 3 roots. So all the factors of the constant, we just have 1 and 2, plus or minus. All the factors of the leading coefficient, which is the number 9, so we have 1 times 9 and 3 times 3. So these numbers create the combination of plus or minus 1 over 1, 1 over 9, plus or minus 1 over 3. We also have 2 over 1, 2 over 9, and 2 over 3. And then again, each one of these has a plus and a minus. So in reality, you have positive 1, negative 1, positive 1/9, negative 1/9, positive 1/3, negative 1/3, positive 2, negative 2, positive 2 over 9, negative 2 over 9, and then positive 2/3 and negative 2/3. So that's 12 combinations that can happen, and only 3 of those are the actual roots. So it's definitely a time-consuming topic. I'm just going to show you here the combination of the synthetic division for all of these. And then again, your goal is to identify which ones have the remainder of 0. So whenever you're doing fractions, if you notice right away that it's not going to give you a 0, just don't even bother calculating. Just stop right there. Like when you get to these combinations, it's super complicated, so that's not even 0. So definitely this one has a 0. So this one works. It's not showing which one it was, but I think it was positive 2/3. Yes. And then this other one, where was it? I guess just this one became the only one that was real. I think the other ones are decimals. That's fine. Yeah. Well, for now, this is the only one that was real root based on our mathematical calculations. All right. So just practice. Hopefully you understand the process of how we can check the possible actual real roots by hand. Good luck.